Hello and welcome to this video on terminal velocity. In this video, we are going to practice questions on terminal velocity. The theory of terminal velocity we have already covered in another video. If you have not gone through that video, you can go through it. Go through the theory section and come back to this video to understand how the questions on terminal velocity are solved. So we'll start with question number 1. You can pause the video here if you want. Try to attempt the question yourself. Play the video again and I'll show you the answer scheme, the answers for this question, the answer key for this question as well in the next slide. Pause the video. Alright, so I hope you are back to the video again. So let us understand what is happening in this question. A plastic ball is dropped from the balcony of a tall building and falls towards the ground in a straight line. So you have a speed time graph for the falling ball. You are given a speed time graph. Alright, look at the axes, speed and time. Let us come to question number, the first part A. State and explain in terms of the forces what is happening to the speed of the ball between the time 2 seconds and 3 seconds. So let us mark the point that they are talking about, 2 and 3. So explain in terms of the forces. You have to talk in terms of the forces. So what is happening in these two sections of the graph? What do you see? What kind of a graph is it? It is a straight line graph. Straight line graph means constant speed. Your speed is stuck to a constant value, which you can read from the y-axis. Constant speed means zero acceleration. So what is happening to the speed of the ball between these 2 points? What do you say? What is happening to the speed? The ball is maintaining a constant speed. Constant speed means you are not accelerating, decelerating, nothing is happening, zero acceleration. Okay, so I've explained zero acceleration. It is a 2-mark question. Is your answer complete? Read the question again. It says state and explain in terms of forces. Have you explained in terms of the forces yet? No, you have not spoken anything about the forces. So what is happening to the forces? What is happening? Zero acceleration means no force acting. Constant speed, Newton's first law of motion. What does it state? If an object is moving and the resultant force acting on it is zero, it keeps moving at a constant speed. Right? Or you can also say it from this equation. Force is equal to ma. The force, the acceleration is zero. Acceleration is zero. The mass would have some value. It is a ball, so it will have some mass. Mass cannot be zero. Right? So if you are multiplying the mass with zero, what is the value of force? The force is zero. It is moving and there is no force acting on it. Why is there no force acting on it? Because the downward force on the ball, which is the weight, is balanced by equal and opposite air resistance. Why is the force zero? Why is the force zero? Because the downward force is cancelled by the upward force of the air resistance. The resultant force on this ball is zero. If this is not making sense, please go through the video on terminal velocity to understand the theory about it. So now you have spoken about the forces, you have spoken about the acceleration, speed, everything you have spoken about in this answer. You'll get full 2 marks here. Right? Let us come to the B part. On this figure, mark a point P on the line where the acceleration of the ball is not constant. Acceleration is not constant. On a speed time graph, the acceleration is constant when it is a straight line. right? Not constant when it is a curve. Where do you see a curve? From here to here you see a curve. So you can mark a point somewhere, anywhere here. So that should give you the answer for B part. Let us move on to C. Calculate the acceleration of the ball between time t is equal to 0, time t is equal to 0 to t is equal to 0.25. Now let's see where 0.25 would come to be. This is 1. Somewhere on the half will be 0.5. 0.25 would be somewhere here, right? So calculate the acceleration. Acceleration at this point 0.25. What kind of a graph do you see here between these 2 points? I'm talking about between these 2 points. What kind of a graph it is? It is a straight line graph. Straight line, right? Straight line. Acceleration on a speed time graph. Acceleration on a speed time graph. It is a speed time graph is given by the gradient. How do you find the gradient? The formula for the gradient of a straight line is y2 minus y1 over x2 minus x1. So let us mark the 2 points. One of the points, let me clear this part of the screen so that we can write here. So you have your points. One of the point could be here, 0 and 0. Other point here. What is the x coordinate? 0.25, and the y coordinate here is 2. 0.25 and 2. Let us say this is x2, y2. This is your x1, y1. Substitute the values in this equation and you should be able to get your acceleration. You should be able to get your answer. Right? Work it out, get the answer. I am going to show you the answer key or the mark scheme for this question in the next slide. So work it out yourself and then tally the answer, which I'm going to show you in some time. Estimate the distance that the ball falls in the first 3 seconds. In the first 3 seconds. So how much is the distance the ball falls in the first 3 seconds? So let's see which 3 seconds is it talking about. I'm going to erase everything. First 3 seconds. What is the time they are talking about? All the way from here till here. So they are talking about everything. All the range of graph that you see here. Right? So they are talking about the area under this graph. They are talking about the area under this graph. Let me shade it. They are talking about the area under this graph. How do you find the area under the graph? Let us break this down into simple figures. You have one rectangle here. You have a rectangle which I am calling R. Sorry, I'll just erase it and correct it. That line was not straight. You have a triangle. Let me call it T. You can use the formula for the area of a rectangle to find the area here. You can use the formula for the area of the triangle to find the area here. Then you can find, you'll have to estimate the area here. You can count the number of blocks. You can count the number of blocks here and estimate the total distance traveled. You have to estimate the total area, which I have marked as a dashed line here. You'll have to count the number of blocks here, right, to estimate the total area. In the next slide, I am going to show you the mark scheme. So you can work this question out yourself and then tally the answer. This is the mark scheme for this question, mark scheme or the answer key. Take a snapshot, solve this question yourself and see that you should be getting all the answers correct after my explanation. Alright, let us come to question number 2. Parachutes are used to slow down a certain racing car. Here this figure shows a racing car of the total mass given to you. You are given the mass. It is slowing down by using parachute. Now the figure here is the speed time graph for 20 seconds after the car reaches the full speed. So the speed time graph is given to you for the 20 seconds. Let us come to the questions now. They are also saying there is one information given at the bottom. At time t is equal to 6, the parachute opens. So what is happening? The racing car is moving at a particular speed. The parachute then opens at time t is equal to 6, as a result of which a lot of air resistance in the backward direction is created. A lot of air resistance is calculated in the backward direction. A lot of backward pull created. As a result, the speed is going down. Can you see? The speed is going down. The speed goes down and ultimately it stops. Ultimately it stops. Alright. Let us come to the part A. Mark a point labeled A where the car is moving at a constant speed. Where the car is moving at a constant speed. Where is the speed constant? If you see, the first flat section talks about constant speed. So you can mark the point A anywhere here. It can be here, here, anywhere on this line should give you your answer for A, the first part. Second part, mark a point B where the car is decelerating at a uniform rate. Uniform rate means constant rate, right? Constant rate means it should be a straight line. Straight line has a constant gradient all throughout. It is a deceleration or acceleration that we are talking about. Same thing, right? Deceleration is an acceleration with a negative sign. So we are talking about constant gradient. Uniform rate means constant gradient. Constant gradient is possessed by a straight line. So where do you see the straight line? Where do you see a straight inclined line? We see a straight line from here. We see a straight line all the way from this point until somewhere this point, right? It is a straight line. After this point, it starts becoming a curve. So this section is your straight line. Straight line, constant gradient means uniform rate of deceleration. So you can mark point B anywhere here. Alright, let us come to the third part. Mark a point labeled C where the car is decelerating at a non-uniform. Not uniform, so that means they are talking about a curve part here of the graph. The curve happens between these 2 points. So your point C can be anywhere here, here or here or here. Just mark one point C, right? So let me see. Let me assume that I'm marking the point C here. Calculate the deceleration of the car at time t is equal to 6.5. 6.5 deceleration of the car at point 6.5. 6.5 you'll have to zoom in and you'll find that it is somewhere here. A point somewhere here. Deceleration, which is same as acceleration, will be given by the gradient. The formula for the gradient is y2 minus y1 over x2 minus x1. Take any 2 points on this line. You have a straight line between these 2 points, right? You have a straight line between these 2 points. You can take the coordinates of any 2 points, A, B, whichever 2 points you find convenient. You can take B here, A here. any two convenient points, write down its coordinates, right? Coordinate of A is easy to write. It is 6 and 70. Why is it easy to write? Because they said that this is the point which is at 6th second that the parachute opened. So this is your 6th second and the velocity was 70. Similarly, you can take any other point. Let's say you can take this point as well, which is 6.5. What is the magnitude of speed? 50. Take one of the points as x1, y1, other one as x2, y2. You can interchange. You can take the first one as x2, y2, second one as x1, y1. Doesn't matter. You get the same answer. But be sure that you should be getting an answer which has a negative sign. The answer should be having a negative sign. Negative sign means it is a acceleration. It is a deceleration. Negative sign means it is a deceleration. Right? What is the resultant force acting on the car at this time? What is the resultant force? Formula is equal, force is equal to, the formula for the force is F is equal to ma. You know the mass already. You know the acceleration. You have calculated the acceleration here, which is a deceleration, doesn't matter. Input the value of the mass, 750, multiplied by the answer that you'll get here. You can include the negative sign. No worries, the magnitude of the force that you'll get will be a negative answer. No worries if your answer is negative. It does mean that the force, the resultant force is acting in the opposite direction of the motion, right? Do not worry if your answer for the force is negative. Just trust the formula. Input the value of the acceleration with its sign. If the force is negative means force is in the opposite direction of the motion. If this is your motion, a force with a negative sign means it is in the opposite direction of the motion. Now the third part, state why there is no resultant force acting on the car at time t is equal to 0. Now this relates to your terminal velocity. This question, last question, relates to your terminal velocity. Let us answer this. They are saying why no resultant force is acting at time t is equal to 4. Where is t is equal to 4? This. So they are talking about this point. Why no force is acting? Look at the speed. The speed has been constant. Constant speed means acceleration is 0. Constant speed, 0 acceleration. When the acceleration is 0, what happens to the resultant force acting? It is 0. Why? Why is the resultant force acting as 0? Because the forward push by the car engine becomes equal to the backward push by air resistance. They'll both cancel out. The forward push by the engine becomes equal to the backward push by the air resistance. Let me write it down. Forward push, which is by the engine, becomes equal and opposite to the air resistance, which is in the opposite direction. Now I'll show you the mark scheme. You can work this question out yourself and look at the mark scheme and tally your answers. Alright, Let us move on to the third and the last question that we are going to practice on the terminal velocity here. So what is happening? A free fall parachutist jumps from a helium balloon but does not open his parachute for some time. The figure here shows the speed time graph for his fall. The point B indicates where he opens his parachute. He opens the parachute at this point. So what is happening? As the parachutist is falling down, the speed is gained. If you see here in this section of the graph, speed is going up, up, and up. The speed is gained all the way. As the parachutist falls down, speed is gained. The backward air resistance is increasing. The backward force of air resistance is increasing. Why? Because the speed is increasing. When you're moving fast, the air resistance increases. Ultimately, the parachutist arrives at the terminal velocity here. The parachutist opens the parachute at this point. Parachute opens. There is a big surface area created. As a result, the backward air resistance increases a lot. There is a backward push. The parachutist is falling down. There is a big parachute open. Air resistance increases. Backward push is increased. As a result, what happens to the speed now? If you see, the speed is going down. Speed goes down all the way. Ultimately, the speed reduces so much that the air resistance also decreases, right? When the speed goes down, the air resistance decreases, right? Ultimately, the new air resistance becomes equal to the downward weight, and the new terminal velocity is increased. This is the terminal velocity. CD is the terminal velocity with the parachute. AB is the terminal velocity without the parachute. This is very important to understand. You have two terminal velocities here. AB is a terminal velocity without the parachute. Without the parachute. And CD is the terminal velocity with the parachute. And that's the purpose of the parachute, to bring down your speed, so that when you fall on the ground, you're falling at a very comfortable and a slow speed, and that's not hurtful to your body. You do not get injured, right? Right, so here you have cases of two terminal velocity. First, without the parachute. Then a new terminal velocity with the parachute, a lower terminal velocity. Why? Because the parachute opens and the backward air resistance increases. The backward air resistance, if this is your, what happens at AB? If this is your parachutist, this dot, weight is equal, the weight here is equal to the air resistance. We are talking about this point. But after point B, what happens? Air resistance increases. This weight will not increase, but the air resistance goes up suddenly. We are talking after point B. Air resistance increases a lot, right? Now the air resistance will go down as you fall down. Why the air resistance is going down? Because if you see, your speed is going down. When the speed goes down, the air resistance goes down and down and down. Ultimately, at point C again, the air resistance here decreases and the air resistance becomes equal to the weight, right? This is your scenario at AB. This is your scenario at CD. And this here is the scenario which is happening here. Air resistance has become more than the weight, which has to go down when the speed goes down. So CD onwards, the weight and air resistance become equal again. So let us attempt the questions now. First part, state the value of the gradient of the graph immediately after time t is equal to 0. What is the gradient here? The parachutist has just started falling, so the gradient here is g. Why? You have just started falling. There's just a downward force of weight. You have not gained so much of a speed. You have just started falling from a zero speed. There is only one force acting downwards. When you just take a fall, you have not gained so much of a speed. So you can say this is the parachutist. The weight is acting downwards. The air resistance upward is almost equal to 0 because you have just started falling, right? Your speed is not so much, right? Immediately after time t is equal to 0. So force is equal to your weight. Weight, the formula is mg. Formula for the force is ma. So what is the acceleration? It is g, right? And acceleration is the gradient. So what should be the value here? G. The answer should be g. So explain why gradient has this value. Why the gradient has this value here? Why the gradient is g? Because you have just taken a fall. The air resistance is almost 0, right? You have just taken the fall. So you have the acceleration due to gravity acting at this point. Come to part B. State how this figure shows that the acceleration decreases between time t is equal to 0 and to time a. Why is the acceleration decreasing between these 2 points? Acceleration is decreasing. Look at the pattern of the graph. It is a curve, right? What kind of a curve? It is a downward going curve, right? It is a downward going curve. A downward going curve means that acceleration is decreasing acceleration. So whenever the curve is a downward going curve, it is a decreasing acceleration, or you can visualize plotting some tangents. If you plot a tangent here, it would look something like this. And if you plot a tangent here, it would look something like this. The tangents are going down. So therefore, the acceleration is going down. C part, explain in terms of forces what is happening in the section AB. What is happening in the section AB? They are talking about section AB of the graph. So what is happening in the section AB? 0 acceleration. Why is it a 0 acceleration? Because if you see, it is a constant speed. Your speed is constant, you are not increasing or decreasing your speed, that means you are 0 acceleration. So therefore, force is 0, because force is, what's the formula for force? Force is equal to ma. Acceleration, when it is 0, input the value mass times 0, force is 0. Why is the force 0? Because the downward weight is cancelled by equal and opposite air resistance. Why? Because the force is equal to weight minus air resistance, right? Which is 0. Why? Because the weight is equal to air resistance. So when you subtract equal quantities, 2 minus 2 is 0, 3 minus 3 is 0. When you subtract equal quantities, the resultant is 0. The resultant force acting between point A and B is 0. So explain in terms of forces what is happening. The resultant force is 0, and this is your Newton's first law of motion. When an object is in motion and the resultant force on it is 0, it keeps moving at a constant velocity. And if you see in the graph, it is a constant velocity. Why? Because the resultant force is 0. Right? Part D, a second parachutist of the same size and mass jumps from the balloon with a larger parachute. He also opens the parachute at B. Sketch a possible time graph for his fall after he opens the parachute. Larger parachute. So the second parachutist is having a larger parachute. So his drop in velocity will be more sudden, and he'll come to a smaller terminal velocity. There will be a sudden fall in his velocity. Larger parachute means you will attain a more comfortable falling landing speed on the ground, right? And also the parachute is large, so there will be much more air resistance created. There will be a sudden drop in the speed. So therefore more steeper line, sudden drop, steeper line, and a lower terminal velocity. EF is your terminal velocity, lower terminal velocity. I'll now show you the answer scheme for this question. Please attempt this question again yourself and then come to this mark scheme. Do not look at the mark scheme straight away. Attempt this question yourself. Look at the mark scheme and see if this mark scheme makes sense to you, if you understand all parts of this question. If you do not, if you have any queries, please type in the comment box. I'll clarify all your doubts. Thank you so much.